Good day everyone, good day sir. Today we are going to determine the polygon field area using tape. The instrument and accessories needed for this are range poles, measuring tape, plumb bobs, markers or chalk or marking pins.
So for the first part is the area determination by base and altitude. The instructor examines the shape and size of the field or site where a structure will be built. Here's an example of a field or site. So observing this example, hindi talaga regular yung shape ng isang field or site na maaari nating ma-encounter. That's why we try to apply different points in the field para mas masukat natin yung sukat ng field or site. So first, the instructor assigns the locations of tied points in the field and the students will mark this point with marking pins or chalk, naming this point as A, B, C, D, and E, which will serve as the corners of the polygon. Then, the chief of party divides the polygon into 3 triangles by taking into consideration that the divisions should be easily measured, naming these triangles as A1, A2, and A3. Then for the third step, measure the base of the first triangle chosen in the polygon using tape, knowing that base can be measured on any of the sides of the triangle. Then, measure the length of the altitude of the first triangle. Additional information, altitude is the perpendicular measurement from the vertex of the triangle to the base.
To get the area of the triangle, divide the product of the base and altitude to 2. Record the length and the base and altitude on the table 3.1, area determination by base and altitude. Repeat the steps for the chosen second and third triangles of the polygon. For the remaining triangles A2 and A3, compute the area of each triangle with the same formula of base times altitude multiplied to 1/2. To determine the whole area of the polygon, add up all the computed areas of each triangle.
Area determination by two sides and an included angle. The same field described in A, area determination by base and altitude, will be used for this method. In simple words, same field in part A. The instructor assigns the location of 5 points in the field, and the students will mark these points with marking pins or chalk, but change the designations on the corners. In other words, use F, G, H, I, and J instead of A, B, C, D, and E. The chief of party divides the polygon into 3 triangles by taking into consideration that the division should be easily measured. Name the triangles as A1, A2, and A3. The students will measure any 2 sides of the first triangle chosen and record these measurements as sides A and B. Here are example illustrations.
Determine the included angle between sides A and side B. Included angle is the angle between the two sides of a triangle. Record this on table 3.2. Area determination by two sides and an included angle. To get the area of the triangle, divide the product of side A, side B, and sine of the included angle to 1/2. Shown below is the formula for finding the area of the triangle. Repeat steps for the chosen second and third triangles of the polygon. For the remaining triangles A2 and A3, here's the illustration of getting its area.
Now, for part C, area determination by Heron's formula. The same field described in part A, area determination by base and altitude, will be used for this method. And then, again, the instructor assigns the location of 5 points in the field and the student will mark these points using either marking pins or chalk. Since this is part C, we will going to designate these points as K, L, M, and O. Next is the chip party divides the polygon into 3 triangles by taking into consideration that this division should be easily measured. Name the triangles again by A1, A2, and A3. Next is that the students will measure all the sides of the first triangle chosen and record these measurements as sides A, side B, and side C.
Record this in the table 3.3 labeled as area determination by Heron's formula. Determine the perimeter of the first triangle taken, knowing that perimeter is the sum of all sides of a polygon or the summation of all sides. We must apply the formula perimeter of the triangle equal to side A plus side B plus side C.
And find the semi-perimeter of the triangle by multiplying the perimeter to 1/2. In formula, semi-perimeter of the triangle is equals to 1/2 times the perimeter. To determine the area of the triangle, substitute the values of the semi-perimeter, side A and B, and side C to Heron's formula.
Shown below is the Heron's formula, where S is the semi-perimeter. Repeat steps for the chosen second and third triangles of the polygon.
For the remaining triangles A2 and A3, use the same formula to get the semi-perimeter, which is the perimeter times the 1/2, and plug it to the Heron's formula.